For the following graph of a function h of x, state the domain and range using both interval and set notation. All right, so this graph of h of x is a rational function. And you'll notice that right here at, would it be, x equal 2, the graph is going berserk right there, right? So I'm putting in a little dashed line there, that vertical line at x equal 2. The graph is tending toward that line, but it's not actually reaching it. It kind of looks like it does in the graph, but the intent is that it's just tending toward that line at x equal 2. So, and with the arrows extending out to positive and negative infinity there, we know that the domain is all real numbers except for x equal 2. Okay, so that kind of domain. It's easy to state it in set builder notation because when you're just eliminating a value or two, you can literally just say that x can't be 2. So for example, in this case, we would have the set of all x such that, we'd use the such that bar, x is not equal to 2. And so in set builder notation, we can literally just say we've got the set of all x such that x can't be 2. In interval notation, we think about the number line. We're including everything except for 2. So negative infinity up to 2, and I'm going to use an open parenthesis there, indicating that we're not including 2, in union with 2 to positive infinity. Okay, so we have to split it up into two intervals. So this U stands for union, which means that we have both of those intervals are included in the domain. But because we're not including 2 in either interval, we're including the entire number line except for just that value at x equal 2. Okay, so now what about the range? So the range, it also has a value of y that it's tending toward but not ever going to reach, right? And in this example, it looks to be the x-axis, right? I'm trying to put a dashed line there at the x-axis. But what's the equation of the x-axis? It's y equals 0, right? So in set builder notation, the range would be the set of all y such that y can't be 0, right? And it can be anything else. If we notice that as the function approaches the vertical asymptote, there are arrows at both ends, right? So it extends, the y values extend to positive and negative infinity, but we just can't include 0, right? It tends towards 0, but it's not going to include it. And then, of course, in interval notation, we'd have negative infinity to 0, open parenthesis there, in union with 0 to positive infinity, right? Again, so that those two intervals include everything except for 0.